Structure of the atom and the periodic table. So this is the first topic of Form 2. So we start with knowing what an atom is. It is the smallest particle of an element that take part in a chemical change or take part in a chemical reaction. So inside the atom, there are subatomic particles, which are namely protons that are positively charged, neutrons that are neutral or they have no charge, and electrons that are negatively charged. Protons and neutrons, they are found in the nuclear and sometimes they are called the nucleons, while electrons are found on the energy levels. So subatomic particles, so I said there is proton, neutrons and electrons. The particle is one, it has a positive charge, that is a proton, and neutron has neutral charge, and electron has a negative charge. The mass of the proton is 1, the mass of the neutron is 1, and the mass of the electron is 1/1840. Atomic number is the number of protons in the nucleus of an atom, and we say that atomic number of an element is equal to the proton number or number of electrons in a neutral atom, because when the atom is charged, then it has different electrons. Then we have mass number. It's the total number of protons and neutrons in the nucleus of an atom. I've shown an example there to explain atomic number and mass number. Sodium, for example, it has atomic number of 11 and a mass number of 23. So the subscript is the atomic number, while the mass number is the superscript. I've also shown the first 20 elements, that is the mnemonic to discuss the first 20 elements. It says, "Hi Hilda, listening to BBC News on Friday night, some ministers and some people seen chasing a police car." So the first one is hydrogen, the second one is helium, the third one is lithium, the fourth one beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon, and potassium, in that order. So for you to be able to count the number of neutrons in an element, because sometimes you'll be asked in examinations, then you're supposed to know that neutrons, it's equals to mass number minus the number of protons, then you get your neutrons. Then isotopes, they are atoms of the same element with the same proton number but different mass number. So normally they just look at in the neutrons. So the more the neutrons, the higher the mass number. For example, carbon, we have carbon 12 and carbon 14. The only difference is that carbon 14 has more neutrons than carbon 12 because the atomic number is the same. Oxygen, the same. We have oxygen 16 and oxygen 17. The difference again is the number of neutrons. Chlorine, there is chlorine 35 and chlorine 37. So the difference again is the neutron number. So isotopes, they are formed because atoms of the same element have the same number of protons but different number of neutrons. The next thing, it's about energy level and electron arrangement. So as I discussed earlier in the structure of the atom, we found out that electrons occupy a certain space that is called energy level, or they are found in the energy levels. So there are as many as 4 energy levels. So because we are discussing the first 20 elements in this matter, the first energy level holds a maximum of 2 electrons. So it's only either 1 or 2, maximum of 2. The second energy level holds up to a maximum of 8 electrons. The third energy level holds a maximum of 8 electrons. So when drawing the electron configuration diagrams, or even when writing electron configuration, the first energy level will hold 2, the second energy level will hold 8, and the third energy level will hold 8, like that, depending on the number of electrons that that atom has. So electron configuration is the distribution of electrons in the energy levels of an atom. For example, lithium, which is atomic number 3, so it's 2.1. the first energy level holds to the maximum, and then the one remaining goes to the second energy level. And that is how the diagram, electron configuration diagram of lithium is drawn. So you just draw the protons inside the nucleus and neutrons, and then you draw the two first electrons on the first energy level and the one remaining one in the third energy level. Magnesium, the same. So magnesium has 12 protons and 12 neutrons. It is atomic number 12. It has a mass number of 24. And so that's how you know the neutrons are 12, because it is 24 minus 12, you get 12. So the first energy level will hold the 2 electrons, the second energy level will hold 8, and then the third energy level will hold the remaining 2 electrons. Relative atomic mass and isotopes. So relative atomic mass is the mass of any atom compared to a single hydrogen atom. So you count it as an average. For example, you mostly given an element, you are given the relative abundance, mostly in percentage of the different isotopes, and then you are told to calculate the relative atomic mass. The first example there is chlorine. Chlorine 35 forms 75% of total mass. Chlorine 37 forms 25% of the other mass. Then calculate the relative atomic mass. So what you do, you will take 75% will multiply by the mass of the isotope of 100 plus the 25%, which is the percentage of the chlorine 37, multiplied by 37 over 100, and therefore you're going to get 35.5. There is an NB that I have stated there, that the RAM is always closer to the mass of the most abundant isotope. For example, the most abundant isotope is the one that has a higher percentage. Chlorine 35 has percentage of 75%, so it's the most abundant isotope. And when you look at the calculated RAM that you've done, you'll get it is closer to the mass of the most abundant isotope, and that is how you know that the answer is correct. Then you have another one. Determine the relative atomic mass of the following elements. You have neon 20, which is 90.92%, neon 21, 0.26%, and neon 22, which is 8.82%. So you apply the same formula. You'll get the mass of the isotope multiplied by the relative abundance of 100 plus 21, the next isotope multiplied by its percentage of 100 plus the third one. Then you add the totals. So there you get 20.179. That shows the most abundant isotope. The RAM is always close to the mass of the most abundant isotope. And in this case, the most abundant isotope is neon 20. That's why you are getting something closer to 20. That is 20.179. The third example is for argon. You have argon with the mass number of 36, and then percentage of 0.34, then 38 with 0.06, and 40 of 9.6. So the same thing, you'll take 36 multiplied by the percentage of 100 plus 38, which is the mass number of argon, 38 multiplied by 0.06 over 100 times 40 times 99.9 over 100. So with that, you will get a relative atomic mass will be closer to the most abundant isotope here, which is argon 40. Then let's look at ion formation. So we normally say that an ion is a charged atom. That means it either negatively charged or positively charged. An atom that has either lost an electron or has gained an electron, it's called an ion. So some atoms, they gain stability by losing electrons from the outermost energy level, or others gain electrons in the outermost energy level so that they can achieve stable electron configuration. Stable electron configuration is electron configuration of 2, for example in helium, 2.8.8 or 2.8.8.8. That means all the energy levels are occupied to the maximum. So atoms normally form ions trying to achieve the stable electron configuration. Let's look at sodium. It's the first example. Sodium has an electron configuration of 2.8.1 because it is it is atomic number 11. So it is easier for sodium to lose 1 electron in its outermost energy level than to gain 7 electrons, so that it has 2.8.8 and the electron configuration. So it loses that 1 electron, and losing 1 electron means that it will also lose the outermost energy level. So that's why you say sodium losing 1 electron to form sodium ion which has 2.8, and then it has lost the outermost energy level. Now it has 2 energy levels. We have another one here, magnesium. For example, the electron configuration of magnesium is normally 2.8.2. So magnesium will easily lose the outermost electrons 2 instead of gaining 6 electrons to become stable, and therefore magnesium will become magnesium ion, which is 2.8, and therefore it will lose the outermost energy level, forming a Mg2 plus ion because it has lost the 2 electrons. On the other hand, there are others that form ions by gaining electrons. For example, chlorine. Chlorine is atomic number 17, so its electron configuration is 2.8.7. It has 17 protons and 18 neutrons, so it will gain 1 electron. And the 1 electron that is gained is indicated using a dot. Remember, the electron mostly comes from another element. When chlorine binds or bonds to, for example, a metal, and it is given an electron, that's why we indicate it using a dot. So generally, you understand that metals form ion by losing electrons in the outermost energy level, because most metals has 2.8.1, 2.8.2, 2.8.3. So it is very difficult to gain 5 electrons than to lose 3 electrons to become stable. So mostly metals form cations, which are positively charged ions, because they lose electrons. So when an atom loses electrons, it forms a positively charged ion. When it gains electrons, it forms a negatively charged ion. So let's look at valency. Valency is defined as the combining power. So you find there are some which are valency 1, valency 2, and valency 3 for metals. Sodium and potassium, it's valency 1. Depending on its electron configuration, sodium is 2.8.1. So that one forms its valency or its combining power. Potassium the same, 2.8.8.8.1. So for the valency 2, you find most of them, they have 2 electrons in the outermost energy level, or they gain 2 electrons to become stable. For example, calcium is 2.8.8.8.2, so the 2 forms its valency. Magnesium 2.8.2, the 2 forms its valency. Zinc, iron, lead, and copper the same. For aluminium, it's valency 3 because it has 2.8.3. Iron, we can have iron 2 and also iron 3. That's why iron has 2 valencies. For nonmetals, we have the ones in valency 1, nitrogen, chlorine, fluorine, hydrogen. All of them, they gain 1 electron in the outermost energy level. For example, chlorine gain 1, fluorine gain 1, hydrogen also has 1 electron in its outermost energy level, so it gains 1 to achieve 2 electrons for it to become stable. Nitrogen, oxygen, and sulfur, all of them, they have valency 2, and then nitrogen and phosphorus, they have valency 3. Radicals. Radicals, they are charged atoms, so we say they are groups of atoms with a net charge that exist and react as a unit during a chemical reaction. So for you to know the valency of the radical, it's normally the same as the charge of that radical. So valency 1, for example, ammonia, it has positive, that is valency 1. Hydroxide, it has OH negative, valency 1. Nitrate, NO3, negative, valency 1. Hydrogen carbonate, HCO3, negative, it's valency 1 also, and also hydrogen sulfate. For the valency 2, it's like carbonate, 2 minus, sulfate in SO4, 2 minus, sulfite SO3, 2 minus, and then the valency 3, we have phosphate, which is PO4, 3 minus. So valency, we say that it's the combining power, and normally it's the same as the number of electrons gained in the outermost energy level, electrons gained. So, but for the radicals, the valency is charge, the charge of that radical. And remember that radicals appear as a unit, so they react as they are. Carbonate, sulfate, sulfite, hydrogen sulfate, hydrogen sulfite, like that. So the next thing is oxidation number, which is the number of electrons which have been removed or added. So for magnesium 2+, oxidation number is +2 because it has removed 2 electrons to become stable ion. +2 ion 3, +3. Hydrogen +1, copper +1, copper 2, +2. If it's copper only, it has not lost anything, so it is 0. Magnesium has not lost anything, so it's 0. And hydrogen has not lost anything, so it is also 0. Then for the chemical formula, we say that it's the representation of a chemical element using chemical symbols, and normally it shows the constituent elements and proportions in which they are combined. So for you to know the chemical formula, you have to know the valency. And what you do is, if you are asked, for example, to write the chemical formula of sodium chloride, you write the element's chemical symbol, sodium and chlorine. Then you write sodium is valency 1, chlorine is valency 1. They exchange the valency, so it becomes sodium chloride. So for the magnesium, it's magnesium fluoride. You see, magnesium is valency 2, fluorine is valency 1. So when they exchange the valency, magnesium will get to, it will be magnesium and fluorine. Magnesium is valency 2, fluorine is valency 1. They exchange the valency, so you get MgF2. For calcium carbonate, it will be calcium 2, carbonate 2. So when they exchange, these ones will cancel out, so you're getting calcium carbonate. If you are given another one like sodium, sulfate, for example, sodium sulfate, what you do, you just write the sodium Na, sulfate is SO4. So sodium has valency 1, sulfate has valency 2. You exchange, so you'll get Na2SO4. So for you to write the correct chemical formula, you just have to know the valency, and then you are good. Balancing chemical equations. So for you to balance the chemical equations, you have to know the valency and also the correct chemical formula. So let's do one example. So you have, for example, sodium metal plus hydrochloric acid. So of course the products are sodium. From the chloride you get the chloride plus hydrogen gas. So sodium, it's written as Na, it's a solid, plus hydrochloric acid is HCl, which is aqueous. It will give you sodium chloride. Now here you write the chemical formula somewhere. Sodium chloride is Na and Cl. Sodium is valency 1, chlorine is valency 1. So when they exchange the valency, you'll get sodium 1, Cl 1. So in short, it's sodium chloride NaCl. This is aqueous plus hydrogen gas, H2 gas. Then I recommend you write the number of atoms present. You have Na here. you have a hydrogen on this side of the equation, and then on this other side of the equation, and then we have chlorine. This other side you write sodium, hydrogen, and chlorine the same. So sodium here we have only one, this side we have only one. Hydrogen here we have 1, this other side we have 2. So you have to balance it by multiplying here by 2. When you multiply hydrogen here by 2, there are 2. Now you multiply here also by 2. Then hydrogens are balanced. Chlorine, this one will affect here, so there are 2. And this other side chlorine is 1. So you'll have to multiply here by 2 so that you get 2 chlorine. And then that one has affected sodium, so now you have to multiply here by 2 because they are already 2, and that is how you balance that equation. Let me do another one. For example, you are given calcium carbonate plus sulfuric acid you're going to get calcium sulfate plus water plus carbon 4 oxide, because a carbonate always forms salt, water, and carbon 4 oxide. So here you have calcium carbonate. You have to write the correct chemical formula. So you can write it somewhere here, calcium, and then carbonate is written as CO3. So calcium is valency 2, carbonate is valency 2. When they exchange, this one cancels out, so it remains the same. So it is calcium carbonate, it's a solid, plus sulfuric acid is written as H2SO4, it's aqueous. So it will give you calcium sulfate. Again, write it somewhere, calcium sulfate. So calcium sulfate is SO4. So sulfate has a charge. So sulfate is valency 2, calcium is valency 2. So they exchange the valencies and then they cancel out. So you have calcium sulfate plus water is written as H2O plus carbon 4 oxide, which is CO2. This is a gas. This is a liquid. So then you write the atoms present. You have calcium, carbon, oxygen, hydrogen, sulfur. The same, they will be on this other side, calcium, carbon, oxygen, hydrogen, and sulfur. So you start asking yourself, how many calciums do we have here? We have 1. This other side we have 1. Carbon we have 1. This other side we have 1. Oxygen we have this 3 plus this 4, that is 7. This other side we have this 2 plus 1, that is 3 plus 4, we have 7. So hydrogen here we have 2. Hydrogen here we have 2. Then sulfur here we have 1. And sulfur here we have 1. So your equation is balanced. So for you to be able to balance a chemical equation, or for you to write a correctly balanced chemical equation, be sure and know how to write the correct chemical formula. That one will guide you and it will help you. The last example, I'm going to do an acid plus a metal. Acid plus a metal. There are more examples in my video. You will check them out later. An acid, for example, I'm going to do an acid, for example, a metal, for example, calcium again, plus, okay, I'm going to do an acid, calcium plus hydrochloric acid. Let me just do that. Calcium metal plus hydrochloric acid. So of course it's a metal and hydrogen gas, which will be calcium chloride plus hydrogen gas. So we have calcium HCl plus HCl, which is an aqueous, to get you calcium chloride. Write it somewhere. I have calcium and chlorine. Calcium is valency 2, chlorine is valency 1. Exchange the valency. So you have calcium Cl2. That is the chemical formula of calcium chloride. CaCl2 plus hydrogen gas, which is H2. This is a gas. This is an aqueous. This okay. So now you write the atoms present. We have calcium, we have this hydrogen, and we have chlorine. This other side we have calcium, we have hydrogen, and we have chlorine. So you balance. Calcium is 1, calcium is 1. Hydrogen, here we have 1, this side we have 2. So you have to balance it. You multiply here by 2, and remember to multiply here by 2 also, so that your hydrogens balance. Then chlorine, now here we have 2, and chlorine we already have 2 there, and now your equation is balanced. And then if you are given, for example, an acid, let's say for example you are given a metal, for example magnesium, and you react it with steam. Magnesium plus steam. You know steam is water in gas form. So you will get magnesium oxide, because a metal plus steam gives a metal oxide plus hydrogen gas. Magnesium oxide plus hydrogen gas. Hydrogen gas. So magnesium is Mg plus steam is just water H2O, but in gaseous form. Is solid. It will give you magnesium oxide is MgO. You write the chemical formula, it's a solid, plus hydrogen gas, which is H2 gas. So you write the atoms present. You have magnesium, hydrogen, and oxygen. This other side you have magnesium, oxygen, and hydrogen and oxygen. So magnesium here is 1, magnesium here is 1. Hydrogen here we have 2, hydrogen here we have 2, oxygen we have 1, oxygen we have 1, and your equation is balanced. So for this and more videos, please subscribe to my YouTube channel, Pinky Science Academy. You'll also get more equations on or how to balance chemical equation, and watch more videos that will help you in your education. Bye.